Okay, so next section we're going to move on to is the different kinds of solids related to their structure and bonding. First one off the rack is ionic solids. So solids are classified according to their properties. Okay, so a property of a solid depends on what the particle is and the bonding with and between. Okay, so today's learning objective will be, hopefully by the end of this lesson, you'll be able to explain the properties of ionic solids in terms of their structure and their bonding. So ionic solids, a perfect example of that is sodium chloride or table salt. So by and large, they have high melting points. They conduct electricity only when molten or dissolved, and they are hard but brittle. So we can now try and explain those properties using structure and bonding. So ionic solids are made of ions which sit in a three-dimensional network of positive and negative ions, so a matrix, I could say. And the ions themselves are held together by electrostatic attractions, ionic bonds. Okay, so you've got a positive cation, a negative anion, and because they are oppositely charged, they're going to attract each other and form this electrostatic attraction. Okay, there's a clear example there. So for sodium chloride, for instance, if sodium is the purple and chloride is the green, you clearly see that every sodium ion cation is electrostatically attracted to 6 chloride anions. Okay, so in terms of melting points and explaining that, ionic solids have a high melting point and boiling point because they are held together by these very strong ionic bonds. Okay, which means that a lot of energy is required to break these bonds. Okay, because high melting point means that you're pushing a lot of energy into the system in order to break these electrostatic attractions. In terms of conductivity, ionic solids will only conduct when they are in the molten or dissolved form. The reason why is that solids, ionic solids, do not conduct because they're in fixed positions, so they cannot move. In order to conduct electricity, you need to have moving ions. And this is the reason why when you melt or dissolve ionic solids, the ions are free to move. So because they're free to move, they can now conduct electricity. Okay, so hardness of ionic solids, they're hard due to these, again, strong electrostatic attractions or ionic bonds between the ions. So that's why they are hard. However, they're brittle because the ions, as was said previously, due to their conductivity in the solid phase, they're in fixed positions. So when you're applying a force, the ions will move out of position, and because they're no longer lined up with positive and negative, there'll now be a negative repulsion. So for instance, sodium chloride will be a chloride close together now, which will repel and push the ions apart, and the crystal will break. There we go, there's an example. Okay, so looking at solubility, ionic salts are usually soluble in polar solvents like water. And so attractions between the water molecules and the ions are strong enough to overcome the attraction between the ions, okay, because from our previous lessons, water is polar, it has a negative part to its to the compound and a positive part to the compound. So the interaction between the positive part of the water and the negative part of the negative ion of the ionic salt will be stronger than the interaction between the two ions of the ionic solid. There's an example there. So you can see the sodium plus is attracted to the slightly negative oxygen atom because, remember, water contains polar bonds, and the chloride ion is attracted to the slightly positive hydrogen atoms of the water molecules. So the bonds between the sodium, the electrostatic attraction between the sodium ion and the chloride anion are broken by the water molecules. And there is a diagram illustrating the hydration of sodium chloride. Okay, thank you.